Hi everyone, so I got a few requests to make a second tutorial on the mineral subject, and I decided to make a second and a third one. On this one, the second, I'm gonna be showing you how I created just a very simple system to get more of a fractal growth on the mineral structure. And on the next one, I'm gonna be showing you how I developed the scene and the shaders both in Redshift and in Mantra. So let's get started. Here we are in Houdini. I'll start as usual by creating a geometry node. Dive inside. Let's start with the platonic solid. I'm gonna choose the dodecahedron, same as I used on the video I showed before. Next, I'll use the same strategy that we used for the previous minerals tutorial. So we'll scatter some points on the surface. Start with 3. Instead of scattering all a lot of boxes, which was what we did before, and on this case we're gonna start by scattering just a few. I'll lower the relax iterations to 1. Let's create some random attributes. I'll start by creating a p-scale value, exponential, so I'll establish a mid value of 0.3 and maybe a minimum of 0.2 and a maximum of 0.8, something like that. I'll copy this one, and in this case I'll make sure it's direction orientation, so 3 dimensions, and it's normal. Okay, so now we have random p-scale, random normal, and we can copy the points. We get this result, and we merge with what we had before. What we get here is the basics of our fractal growth system. The only difference is that we're going to do several iterations of the same process using a for each loop. In this case, a for each number. We'll also make use of the metadata contained on the for each count later on. Now we just grab everything, we can put it inside. Basically what we want is to make sure that everything connected here, and this is just the input, and the output is also connected. So with one iteration we get exactly the same thing. We should see different progression of the process with as we increase our iterations number, but right now the for each loop is fetching the input on each iteration, and I wanted to fetch the feedback from the output. Okay, so and now we do see the growth happening. This is the growth we get. And change the background color to dark. As you can see, we get some kind of fractal effect where the basic structure keeps repeating, get more complex, repeats again, gets more complex, and repeats again. So we get this type of effect. The main issue, the main parameters that are going to contribute to the look of your final result is going to be mostly the attribute randomize the p-scale. If you set different values here, let's say the maximum limit is 0.9, changes a lot. The minimum value, let's say 0.3, and the mid value is 0.4. Again, keeps changing. It has a lot of effect on the final look of your of your mineral. And the other thing is the amount of points that you scatter. What we'll do next is implement a way of making sure that on each iteration we get a random number. Instead of on every iteration having a total count of 3 points that we scatter, we'll make sure that those points will vary from 1 to 5 or something. So, but before that, let me just explain you something that we also should be taking into account. So this is the result of the first iteration. We used this object as our base, we scattered points on its surface, and we got this result. On the second iteration, what we're going to get is we're going to be scattering points on this surface, or on the surfaces of these objects. And as you can see, some of those surfaces are actually inside other objects. If you want to make sure that you don't scatter points inside, what we need to do is, before we scatter the points, we need to get rid of the surfaces that are inside. We can do that by doing a VDB from polygons here, right at the beginning, with a good amount of resolution. I'll go with 0.02, and we'll convert this back to polys, convert VDB, convert it back to polygons, and we get this. And now we can scatter those points. So on the next iteration, when we have this final result, go to the second iteration, we'll see that here we'll only be scattering points on these. There's nothing inside anymore. Okay, so that's a quick way of getting making sure we don't scatter points, and by consequence we don't copy objects inside. The other thing is, we might want to have things a bit more compact as a way of making sure that the volumes intersect each other more. And we can do that by adjusting the ISO value here, just to push things inward a bit, minus 0.02 or minus 0.01. I think this is enough. Just slightly push inward, or I think we should avoid going too drastic on this, but a slight push inward is also going to give us a different look, more compact. So this is what we get now. Let me go to, let's say, 5 iterations, and this is what we have. Remember that the growth is exponential, so everything is going to be, the piece that we see here is what's actually going to be scattered across the surface on the next iteration. So things tend to get very dense and very quickly. Just to show you, I go to the 6th iteration, we get a lot more polygons. 7th iterations, okay, we get a lot of geometry here. Very interesting structures, but a lot of geometry. I'll stick with 4 for now as a base. And let's implement the variation that I was talking about earlier, making sure that this total count is going to be between 1 and 5 on each iteration, using the attributes, the detail attributes that are on this one. Remember, on this metadata node, we have access to iteration, value, num iterations, and value. And these are values that are going to change on each iteration. And we can use that as a seed for a random expression, and then just fit that random expression, that random number that goes from 0 to 1, and fit it between the range that we want. Let's do that. So on scatter, I'm going to say that I want to calculate a random number taking into account the detail attribute from that particular node for each count. It's the parameter iteration that I'm going to be using. And so this will give me a random number from 0 to 1, and I want to fit 0 to 1 between 1 and 5. And now we have a completely different look. On some iterations, we'll have 1, and that number of points that we're going to be scattering is going to vary from 1 to 5. Now, I always like to have global control whenever we have these random numbers having an effect. We have a seed associated to it. So as you can see here, the scatter has a seed, and both these attribute randomizers will also have a seed here. So what I'll do is I'll create a null. I'll change the shape to circular and the color to red, just to make it more obvious. I'll call it controls, and I'll go to the edit parameter interface, add a float. I'll call this my seed. Apply accept. I'll copy this parameter, copy parameter, and here on the scatter, I'll make sure I add that value, plus base relative references. And same thing here on these seeds, plus base relative references, and here as well, plus base relative. Done. So now we have the ability to generate variations. Even if the parameters are all the same, just by changing the seed number, we'll get a different variation of the object. Pretty interesting. The other thing that we want to do now is thinking of how we're going to shade this. It will be interesting for us to grab some information out of this before we actually merge and fuse all this geometry. So I'm thinking we can go over each one of these pieces. They're all separate. Each one of these little pieces and calculate the area of each one of these. And then each one of those pieces will have a value that's going to be representative of its size. And when we shade, we can create some variation based on the size of the object. Okay, that might be interesting as well. So what I'm going to do is I'll create a for each connected piece. And for each connected piece, I'm going to be using a measure, the Great Measure 2.0, and I'll measure the area. This parameter, this attribute is going to be saved on the primitives, okay? But I'm going to promote this attribute to points from primitive area, from primitive to point. And since all the primitives actually have the same size, it doesn't really matter what you choose here. It's going to give you the same result. So now we have points, and every point has a different area value. Our areas are going to range between, let me just make sure, area, reach. So our area values are going to range between 0.86 and 0.01. So almost between 0 and 1, which is great for us to be able to control that. Now, the next thing I'll do is I'll start to taking care of the geometry to make sure that everything is properly merged. You might want to leave it low poly like this, but I usually rather have it all merged. So I'll do again PDB from polygons. PDB from polygons with a good amount of resolution, very small voxel size. This is too much. 0.01 probably enough. Yeah, let's see, we have 1 point, not right. Yeah, sorry. Still need to convert this back to polygons. So 1,400,000. It's good. I think it's a good resolution. We have some sharpness on the transition of these planes, which is something that we want. Next, we need to transfer back the information that we had here, the area attribute. We don't have it anymore. So we'll use scatter. I'll use density instead. Something fairly high, 800. If you want the scattering to process faster, just disable the relaxed iterations. For now, I'm going to leave it on. So I have 300, almost 400 points, but it should be a good approximation to do a nice attribute transfer. I want to transfer just the area per attribute. And on the conditions, on the distance threshold, we should use something similar to this, probably double, 0.02, and nice blend, 0.02. There's a quick way for us to actually see what's happening. If I control middle click, I have access to the parameters and the data from this node, and I'll just control click on the parameter that on the attribute that I want to visualize, and automatically Houdini will create a visualizer for me, which is great. So everything looks good. We have a nice transition between these values. And the next thing I'll do is just blur out some of this information. I'll just do an attribute blur. I'll say I want to blur out the area, and let's say maybe 4 iterations, just so we don't have those sharp artifacts working against us. This looks good. Let me just disable the visualizer. Same process exactly. And this is it. So now we have a really quick system for me to show you how we can get some fast variations. I'm just gonna here disable the relaxed iterations. I'm gonna grab this. One last thing I'm gonna do is make sure I have normals, and that my object is actually floating above ground level. Just to make it easier for me to render it out and set a nice scene after. So I'll just add transform, and I'll take into account the minimum value of y and just invert it. So bbox, my input 0, dimension underscore y min. Okay, now I'm going to invert this, and it's on the surface, but I want it to be actually floating above, so I'll just add plus 0.5, and it's going to be floating above the surface. Again, set up a camera. I'll just zoom in slightly, and we'll do some nice shading and lighting on this file, on this version. But just so you have an idea of, let me change the name of this to minerals 2. Gonna be processing everything again. Fine, pretty fast. Now here on the controls, if I like the number of iterations I have, the size variation that I have, and I just want to create more variations, I just go 0. Gonna give me just changing the seed 1. Nice, but I think the one we had was kind of interesting, 1.77. Yeah, I think I'm gonna go with this, and that's it. So let's just create an output null Probably not going to be using it, but just in case. So this is the system, pretty straightforward. Again, basically just a for each loop that goes where we have control over the amount of iterations that we have. Right now it's just 4. We fit in a platonic solid, which you can change for anything else that you might want. Let's try a sphere. Okay, if you change the input, this is all gonna still work out. Also interesting structure. If we use different type of platonic, let's say tetrahedron, might also be interesting. Pretty cool also, I think. Really nice. So just explore. Now I'm gonna keep with the dodecahedron. So here on my switch, this would be something that I would also just associate with my controls, but for now it's just, that's not the purpose of this tutorial. So I'll just switch back to the dodecahedron, go to my camera, and we'll stop here. And on the next tutorial, I'm going to be showing you how you can light and shade this type of object. And I'll be shading and rendering both in Redshift and in Mantra. Hope you liked it, and I hope to see you on the next one.